We on? There we go. I love being known now as Mr. Watson. I will take that home to my kids. All right, well, very good. Thank you very much for having me here today. I am, as you heard, the CTO for IBM Watson. I've been with the team now for quite some time. And I want to take you back. It's been actually almost 6 years since we introduced Watson on the Jeopardy game show. Hopefully, some of you had a chance to see that, where we used Watson essentially to compete with human beings at the task of answering questions. Questions of fact, or factoid, as we like to say. Questions of open domain knowledge, questions essentially of trivia. But to be able to do that, and doing that was not just a publicity stunt. It actually was a demonstration of a fundamental shift in our industry around the use of computing systems to perform what has largely been presumed to be a unique human task. And the task itself was profound in that we've been trying really for about 60 years, almost 70 years, to create artificial intelligence in computing systems. And up until that moment, our success rates were quite dismal. It is generally accepted that our average accuracy in artificial intelligence systems up until that point in time sat around anywhere from 25 to 35%, depending on the circumstances, depending on the use case, which is nowhere near the level of proficiencies that we as human beings carry, and therefore was nowhere near what was necessary in order to be able to perform that simple task, the task of answering questions. The reason that problem was actually quite interesting and hard was because it dealt with the human condition, that is, human language. Our human forms of expression are incredibly ambiguous. They're full of subtleties, innuendos. In the game of Jeopardy, we were dealing with puns and misdirection. Devices that in language are served for the purposes of directing our attention somewhere else when what we really mean is something else. And that, of course, is unique to the game of Jeopardy, but it's actually not unique to our everyday language. It's not something that we don't find very often. We actually find this quite often in our communication with each other. And as a result of that, the task of trying to understand the nature of the question being asked, and be able to understand the literature, and from that, be able to find answers was a huge breakthrough. And to be able to compete with these humans, we had to be running the Watson system at about 82 to 83% accuracy, which in some systems you can argue is not enough. But clearly in the task of competing with human beings at trivial questions was sufficient. Since then, a lot has changed. In fact, probably the most remarkable change is that we've kind of changed the way that we think about the utility of this thing that we call AI. In fact, we no longer even refer to it as AI, as artificial intelligence. It's not about trying to replicate the human mind. It is about trying to augment the human mind. So we now call this augmented intelligence. It's about amplifying our own natural human cognition. It's about recognizing that all of us as human beings have a tremendous capacity to take a situation, assimilate that, understand it, devise a plan and strategy for responding to it, and acting that out. We have a remarkable ability to recognize meaning in the patterns of signals that oftentimes are not all that explicit, as evidenced by our language, as evidenced by the way that we see the world around us and recognize shapes and images and actions being performed in our visual perspective, our ability to listen and hear and understand even subtleties about human emotion, human uncertainty, all the things that kind of go into who we are as human beings or the world that we live in, and be able to take those signals, make meaning out of them, and then apply that to figure out what to do. So while we as human beings have tremendous capability there, we also are quite flawed as well. We carry with us a limitation on the number of things that we can read. We have a limitation on the number of patterns that we can recognize beyond the obvious. We have a limitation on how much of that we can recall, retain, and bring forward at that moment where we're in a crisis and need to know the right thing at the right time. We also have biases and prejudices that color and cloud our judgments. These are natural human attributes, but they are also limitations. And in a world where we're starting to see an explosion of information, those limitations are preventing us from making the right decisions at the right time. So we've taken this and we've started to formalize what we now refer to as a cognitive system, a system that can understand our world, our forms of expression, our experiences, the world as we see it and hear it and touch it and feel it, taste it, smell it, all the senses that we have, and even the things that we as humans don't possess in terms of sensory perception, we can apply the same technique to understand and perceive what's actually there, to take that then and reason about it, to apply both inductive and deductive reasoning approaches to figure out whether there's something that we can do with that information, whether that information means something that's important to us at a given time. To be able to train these systems, because frankly, if you were to sit down and use the same traditional techniques of programming that we've used really for the prior 67 years of our information computing industry, you could never write all the conditional logic that's necessary to evaluate the different conditions under which these experiences might occur. You simply couldn't do it. Even if you could write the millions and millions of rules that would represent the different conditions that we experience and those that we don't experience but we might anticipate and might need to know in a case that we are now in a new situation, even by the time we got done writing all down those millions of rules, the world would have changed. Somebody would have learned something new that changed our perspective or introduced a new idea that we hadn't considered before. And so we can't really use those techniques. Instead, we've come to rely on statistical analysis, analytic algorithms, and more specifically, machine learning-based algorithms that begin to recognize patterns by having been exposed to many examples of that same pattern and its attribution to meaning in the past that then will continue to do a good job of recognizing things in the future, even when it's now exposed to things that it had never seen before. And finally, these things have to be able to interact with us in a style that is natural for us. We've got arguably tens or hundreds of thousands of years of evolution that have honed the way that we as human beings communicate with each other. And while it may be ambiguous, it's also very efficient. It's what we were born with. It's what we learn throughout life. It is the experience and the exposure to expression that we are so deeply conditioned by. And then when we have a computing system that forces us to move out of our natural forms of communication into one that is constrained by the limitations of how that computing system works, it forces human beings to have to adapt. It forces us to have to go through a translation to recognize how to both understand what the computing system is telling us as well as how to then affect the computing system to act on our behalf. And that takes time. That takes away from our response that may be critical in a moment of crisis. So moving now to systems that can now interact with us using our language and our forms of speech and interactions that are natural for us is a big challenge and something that we now classify as being part of what we call a cognitive system. Now, there's a reason for why all of this is occurring right now, and it's not just because we happen to play the game of Jeopardy and there was a lot of response to that, but rather there's a phenomenon that I think we all are somewhat familiar with, and that is this enormous explosion of information that's being produced. As of last year, 2016, we were generating about 2.5 exabytes of data a day. Today, that's closer to between 10 and 15 exabytes of data being produced every single day. 10 exabytes of data being produced every single day. Now, a lot of that, of course, is traditional structured information, the kind of thing that computing programs have been designed to handle since their inception. A lot of it is in this form of natural language. It is literature, it is books, it is emails, it is papers, it is all the things that we as human beings write down to communicate with each other. A growing amount of this is in sort of the media space, the recording of audio, the transfer of video images, whether those are still pictures or moving pictures. And then a lot of it is in what we call the IoT space, the place where devices in our life, whether those are in our vehicles or in our equipment or in our rooms or our spaces, that are instrumented to have some perception, or at least some sense of what's going on in that space. All of that data is coming in and burdening our systems, but more importantly, it's burdening us as human beings. We can't keep up with it. We can't understand it all. We don't know how to take and make good use of that information, and it's just growing. This slide is slightly out of date. We estimate now that by 2020, we'll see about 160 zettabytes of information being produced every single day. So that's what's driving these systems. That's what's driving us to refine and evolve these cognitive capabilities so that we can use these cognitive systems as a way of amplifying, as a way of bringing, sort of, if you will, a different perspective to the kinds of decisions that we need to make. Not only to be able to assimilate the information that's available to us and make use of that to be able to identify the patterns that might be relevant to a decision, but also to cause us to think through the alternatives that we might not otherwise be thinking about. We have a case that is somewhat well publicized, working with Memorial Sloan Kettering in the oncology space, bringing to the attention doctors treatment choices for their oncology patients that many times are the ones that they would have thought of for themselves, but sometimes are the ones that they would not have thought of. And rank ordering those based on what's not important about that treatment, but rather how that treatment might be applied uniquely to that patient. And that information is enabling doctors to reduce their error rates from about 40% today to something dramatically less than that. It's saving lives. It's improving the cost of treating these patients. It is, of course, improving the end result and the lifestyles and survivability of that insidious disease. And that's just an example of where, by examining the data that's available, by bringing evidence to the table at the moment when a decision is being made, that is not based just simply on our own personal experiences, but combines our experiences with what is available to us in the literature or in the information space around it at that moment where we're making a decision. Now, about 3 years ago, it became quite obvious that having done what we did with Watson for Jeopardy and all of the use cases that came out of that we could not keep up with it. That we as a company couldn't keep up with it. In fact, we as an industry couldn't keep up with the demand for all the different use cases that people could imagine where this kind of technology would benefit them. And as a result of that, we made a decision, a fundamental strategic decision, one that I think that every vendor out there today who's in this area is also making, which is to say, rather than focusing our time and attention on solving the problem that you have, let's distill these problems into a set of building block componentry, a set of individual services that by themselves are discrete and focus on only doing one thing, like looking at people's imagery and trying to identify what's in that image. That by itself is an interesting task. And create a platform where people like you or others who are into this business can go off and create your own solutions to the problems that you face by assembling these building blocks into that solution, by taking advantage of their availability, in our case, in the cloud, so that that is immediately available and not something that you have to go through a long procurement cycle for, but rather you can just begin to make use of immediately. And as we go forward, of course, making sure that these things are secure and protected for both classified and unclassified use cases. So we made that pivot about 3 years ago, and as a result of that, we now have a collection of services which I put into 3 broad categories. And I modeled this after the work that Daniel Kahneman did around the fast and slow mind. If you ever get a chance to read his book, it's certainly worth understanding his theories about how the human mind works. But what I found intriguing was this idea that you can classify the systems of reasoning in a human mind as what we would, in the lay speak, refer to as subconscious thought processing versus the more conscious thought processing, the higher order forms of reasoning that represent deep cognitive energy. And so I applied that in the structuring of these services, and so they're categorized around what I call higher reasoning skills, which you can associate with Kahneman's System 2 or our conscious thought processes, those things that take more time to reason about, things that take more energy, where you want to evaluate the choices and the trade-offs and where those trade-offs are important to affecting different decisions under different circumstances. That's what I refer to as higher reasoning. And today, we have 2 services in that space, one of which is where we will continue to grow out more and more deeper reasoning capabilities. And I'll come back and talk about the other space, but just to give you a heads up on that, that's what I call foundational cognitive skills. We'll come back to that. But to begin with, let's talk a little bit about conversation and discovery. Now, conversation happens to be one place where people are more commonly applying these technologies today, at least in the commercial space. Conversational systems, or what some people refer to as chatbots, are becoming very common in any space where there is an interaction between human beings today that could be supplemented by a digital agent that's solving for at least some of the kinds of things that occur in that interaction. So it's very common, for example, to find this stuff in support systems, right? You go out, you buy a product, you now get it home, you've been using it, it fails, you need to go talk to somebody about how to go fix that. Well, today, your choices are essentially to call up a 1-800 number or get on a website and look around at forums, or get to their website and look at all of their marketing literature or other manuals, all of which is either time-consuming, error-prone, or likely not to lead you to the answers that you're looking for. So instead, chatbots are a way in which you can enter into a conversation with a digital system that will simply answer your questions. That's what we refer to as a conversational system. A discovery system is one where we don't focus on the conversation, the style of interaction, what does it mean to try to get underneath your issues, but rather where we focus on the question and the different ways in which we can apply reasoning to answer that question. As I mentioned before, a lot of what we do is done in the area of what we call inductive reasoning. The inductive reasoning is essentially the task of finding answers that have already been captured somehow, somewhere. Answers that exist in literature, answers that exist in a database. Inductive reasoning is a process of taking a natural language question, understanding the question, understanding the intent of the person asking that question, and then finding that answer as it exists in whatever form it's in. And of course, that was the big breakthrough with the case of Watson, was this ability to read, the 200 million pages of literature, to find the answers in that literature that serve as a reasonable answer to that question. The same thing applies in real world as well. We have lots and lots of manuals, lots and lots of papers, lots and lots of books out there that contain answers. Now, there are different kinds of answers, depending on the nature of the question you're asking. In many cases, questions that we ask demand a fact as an answer, a factoid, a noun phrase that represents the answer. There's other kinds of questions you might ask as well that require more of a descriptive answer. So the difference between what's the capital of Austin, which is demanding a fact as an answer, a noun phrase, what's the capital of Texas? Austin is the noun phrase that answers that question, versus what does it take to get insurance in the state of Virginia, which requires more of a description. Those differences require different kinds of reasoning. As we move forward, though, we're going to see more and more focus on what we call deductive reasoning, which is deductive because the answers actually don't exist. They have to be produced. And the way that we produce those as human beings is by having experience, having knowledge, more specifically, having encoded the axioms of our knowledge in that domain, our expertise in that domain, in a form that allows us then to produce new answers by simply exercising those same axioms. Now, not all axioms have sort of the mathematical purity or the precision that we typically associate with mathematical axioms. Some of these domains, it is much more abstract, right? You go talk to an oncologist about what logic they would go through for determining what treatment to consider or what test to perform to be able to determine what treatment to go through for their patient, and you'll find that they actually can't answer the question, right? They can't tell you what that logic was. They've built up that logic through years and years of experience that they've assimilated and have encoded into what we now think of as intuition. That is what deductive reasoning is going to be about. Deductive reasoning is about trying to capture those kinds of axioms that are very abstract but symbolically represented in a way that allows us then to compute new answers. This is a frontier that we're just beginning to embark on. And those are the kinds of things that we do in discovery. In the conversational space, I want to highlight one particular aspect that makes this particularly different than most other chatbot systems you see out there today. Most of the chatbots that you may experience today are really designed to handle your question. Just your question, right? Or your command, or your statement, right? If I ask my conversational system, what's my balance? It can answer that. And that's a good thing. But the thing we have to realize is that when I ask, what's my balance? What's my account balance? That's not my problem. My problem is I'm trying to get ready to buy something. Or I'm trying to figure out how to save up for my kids' education. Or I'm trying to figure out how to get my money in the right place so I can pay my bills this month. There's something deeper behind that initial statement. And the conversational system, and what makes it powerful from a cognitive standpoint, is when it can get behind that initial question and really get to the root of why you asked that question. What is the issue that you're really trying to deal with? And when you get a digital system, a conversational system, a cognitive system that's capable of understanding that your real intention here is deeper than what you just expressed, and what guides you through a conversation that will allow you to get to the real issue, then it's going to be much more helpful than the kinds of things we're seeing today most commonly. And that's what we're pursuing here with our conversational agent. So I want to give you a very quick example of a conversational system. And in this particular example, we're not putting this on a chat box like you would typically see. This is not something you're going to find on your cell phone. It's not something that you're going to find on your whatever device you may have in your home or on your laptop. In this particular case, we've taken an entire conference room, and we made the room the point of interaction between the human and the machine, the conversational system in this case. I'm using a commercial business use case to demonstrate this with. This is one about mergers and acquisitions, but you begin to get the idea that our conversational systems as we go forward are going to change the nature of the way that we think about interfacing with our computing systems in the future. A real quick disclaimer here, no, we're not interested in any of the businesses that we're going to demonstrate here.
Hi, Jeff.
Hi, John. Hi, Celia. This is Jeff Kephart speaking.
Hello, Jeffrey O. Kephart.
So what would you like to cover today, John?
I'd like to go back and cover Project Zinnia, if we could.
Jeffrey,
Yes, Celia?
it sounds like you're interested in acquisitions.
Mm-hmm.
Would you like me to restore your most recent work session?
That would be great. Celia, restore my last work session. We were working on decisive analytics. There's the website for it. I have the sense that you like this company a lot.
We have a strategic gap in this area, and Decisive Analytics fills that gap very nicely. We should look at more companies like Decisive Analytics.
Okay, so we could place decisive analytics at the center of the universe of companies and explore from there. Celia, find companies similar to the company named Decisive Analytics.
I found 100 companies that are similar to Decisive Analytics Corporation.
This is excellent. I see a couple of companies that I recognize, but the total set of companies is much broader than I would have been able to come up with myself.
Good.
I'd like to explore this in more detail.
Celia, tell me more about the company named Strategic Analysis, Inc., focused on business.
Okay.
Okay, so here's some information about it. What do you think, John?
I think government professional services, and they do software development. I think this is an excellent candidate.
Good.
Maybe we can limit the revenue numbers of these companies to be between 20 million and 200 million.
Sure. Celia, highlight companies with revenue between $20 million and $200 million.
Okay.
Maybe we can start to examine these in more detail and work through some decisions.
Oh, sure. Celia, shrink the graph window. Celia, show me a decision table.
Here is a decision table that allows you to compare companies side by side.
Okay, we can make this easy. Celia, place the top 8 companies in the decision table.
Done.
Place attributes, business description, score, and number of employees, and revenue, and year founded. Okay, is this what you want?
I think we can use this to make a rough cut on these companies.
Okay, we'll stop there. You get the idea. The point here, though, is that the interaction that's occurring here. And by the way, all of that is live code. All of that is a live running system. Obviously, we deploy it into our demonstration center for the purposes of conveying this idea, but it's a basis by which we can experiment with new kinds of human-machine interfaces that, again, notice there was no keyboards involved. There was no, mouse gestures involved. It was all about verbal interactions, about explaining what you need, having the system understand that. You may have noticed at the very beginning there was a moment when Celia actually interjected into the conversation by listening to what was going on between John and Jeff, recognizing there was a piece of information that Celia had that she might want to offer for these folks to look at. We obviously are going to continue to evolve this, but the point being to try to get you to think about the other ways in which we're going to see these kinds of interactions occur in the future, and that we're not going to be limited just to the things that we've seen in the past. Now, I want to go back to, as I said, we have these foundational cognitive skills. Our greatest asset today is in the area of language. These are the things that we've been working on for the longest. But in the spirit of what I've said, Kahneman brought up in the System 1 systems, subconscious thinking, most of what we do there is about recognition. It's about taking a document and recognizing what subject is being discussed in that document, who authored that document, when was it authored, what are the main relationships that are being represented, who are the entities that are identified in that document. Or in the area of speech, being able to recognize voice and language and expression, verbal expression, and by the way, be able to express that back. You saw that being demonstrated in the video. In the case of visual recognition, being able to take a still image or a moving image and recognize the objects that are in that, understand their relationships, understand the dynamics that might suggest the scene or the actions being performed within that image. And then finally, in the area of empathy, using psycholinguistic analysis, we can identify about 52 points of a person's personality by examining a minimum about 300 words of something that they authored. It could be their blog, it could be their emails, it could be their tweets, it could be a paper they wrote. As long as they wrote it, we can determine something about who they are simply by looking at how they write. How you write says a lot about who you are and your personality. But we can also look at things like emotion and tone. And there is a very subtle and important distinction between the two. But by, again, recognizing how people are writing says a lot about what emotional state they're in, that's emotion detection, or what kind of emotional effect they're trying to create in other people, that's their tone. All right, just to give you a better example of what I mean by that, I'm going to take you through this demonstration. This is actually taken from a dating website where somebody is putting together a profile, explaining themselves for the purposes of trying to find a date. And as you could expect, there's a lot in this that sort of is intended to demonstrate the best of this person as they see themselves. So just to give you some examples here, if we were to look at this overall expression, this overall profile, there's a lot of joy in this, right? This person is expressing a great deal of joy. They're trying to create a tone of joyfulness in this, although there's a little bit of anger in here too. As we begin to decompose this, begin to see a slightly different picture show up. Well, first of all, we see this first paragraph, what I'm doing with my life, working toward a new goal, keeping fit, helping others, and traveling whenever I get a chance. Again, high probability that people, when they read that, will get the effect of joyfulness. They will hear the joyfulness in that expression. Take a slightly different statement here. I'm really good at listening, enjoying the moment, and many other things. Turns out a number of people here will hear sadness in that statement. Right? Why is that? Probably because it tapers off. Right? I'm really good at listening, enjoying the moment, and many other things that I'm too tired to tell you about. That tone comes out. People will hear that in that expression. Right? Another one. I raised two great kids, and now I'm starting a new chapter in my life. A lot of people hear anger in that. I raised two great kids, and now, damn it, I'm having to start all over again. Right? She left me. She took all my money. People will hear that in that. The point is, this kind of analysis is very useful when we're trying to understand a person. Understand both how they're feeling emotionally, but also what kind of tone they're trying to convey, or more specifically, what kind of tone other people will hear when they hear from that person the way that they wrote it. Right? You can imagine using this almost like a spell checker, right? Just before you send that memo off to your boss, right? Tone check it. Get an idea of how they're going to hear what you just said. Are you going to create the effect you're looking for? If you're out messaging to the public, right? You've got marketing messages or other things that you're trying to convey, or to, decision makers. What tone will they hear? Is that the tone you want them to hear before you expose what you just said to them? Of course, we're using this, first of all, in conversational systems to understand what emotional position a person is in at any given state of that conversation, because even like we do as human beings, we want to be able to influence the direction of the conversation. Right? We want to take this in a direction that is meaningful to the outcomes that we're trying to achieve. There's other cases where we're taking this and using it to look at how to pair up people. In the commercial space, again, using the support center as an example, when a customer calls in, pairing that customer with the right agent whose personality is complementary. Or if it's a conversational system, understanding their emotional state so that we can guide them through that conversation to getting to a more satisfied outcome. Those are the kinds of things that we're doing with these cognitive services. As I said, we've put this into a platform that is highly robust, it is highly secure, and we're continuing to evolve and improve the scalability of the system. It is very likely that almost all of us, and almost everybody that we know in both the defense and civilian space, will be exposed to these systems as we go forward into 2018. If you're not already using them, you will be. There's a good chance you are already using them. We expect that about half the population will be using these kinds of conversational systems, these cognitive systems, by the end of next year. That also means, though, that we're going to be exposed to these things through billions of devices. It's no longer going to be about the smartphone that you carry around or the laptop that you have. Those are not going to be your only points of interface. Every place we go in civilian or in the defense space is going to be exposed to places where the interface to these conversational and cognitive systems are going to be there at the moment that we arrive. They're going to be in our conference rooms. They're going to be in our vehicles. They're going to be in our command centers. They're going to be in our rooms, right? Where we live, in our homes, right? They will be there wherever we go. They will be in our cars. We're doing work right now with General Motors to take OnStar and expand it to now be a conversational system that not only is there for any roadside assistance you might need or navigational assistance you might need, but actually is your point of interface to the car. The car essentially is going to come alive to you when you get into it. It will know who you are. It will know who you're with. Right? It'll know your preferences. It'll be able to use its understanding of your emotional state and your intention and your goals to be able to predict and provide for you suggestions about things that you might need from which you can pick. It will help us in the decisions that we make at work and at home and wherever else we go. So to support that and recognizing that more and more of the compute capacity is being pushed out to what we call the edge, these devices, the things that we used to think of as being just dumb sensors, more and more often these devices are gaining more and more compute capacity on them. They have more processor capacity, they have more memory, they have more storage space on them, and they're in many cases connected to our networks. And so what we've been doing recently is trying to figure out how to take our cloud-based cognitive services and other analytic services and push them out to the edge in a controlled manner, in a way that we can secure the workloads and understand what is out there, but do so in a way that's highly scalable. Because if we're going to have billions of devices out there, guess what? You're not going to have somebody at each of those devices to manage it. You've got to have some centralized management capability. And so trying to both enable our cognitive capability to be pushed out to the edge, as well as using our cognitive capability to manage getting that to the edge, is the next major phase that we're going through. And then finally, if you're going to have billions of devices, you're probably talking about trillions of connections. And I don't mean just connections, hardwired connections or wireless connections. I'm talking about connections between people and their information, people and their applications. All of the different kinds and styles of connections that exist out there. And the issue that we're going to run into there is accountability. Who was doing what, where, when, and what were they doing it with? And so for that, we're now focusing on how we leverage blockchain as an accounting mechanism, as a distributed secure accounting general ledger for accounting for all the kinds of connections that people create between themselves and other people, between themselves and their devices, between their devices and their computing systems and information they make use of. And then finally, we are all exposed to a growing threat of people attacking our systems, attacking ourselves through those systems, attacking the information that is contained in them. And so applying cognitive computing to help address the cyber threat, the cybersecurity problem that we all face in both the defense industry as well as in civilian industry. Right? We're all exposed to essentially the same kinds of problems, although certainly the effect, the consequence of these attacks can be quite different. But nonetheless, the problem remains the same, which is that we have bad people attempting to make use of our capabilities, our computing capabilities, to do bad things. That's what we're trying to identify and recognize. The first issue is that in many cases, even if you know that you're being attacked, even if you know that a threat attack is underway, how do you respond to that? And of course, there's lots and lots of mitigation and remediation plans that have been put together out there, but now the issue is that the folks at the Security Operations Center, the security administrators who are responsible for protecting these systems and mitigating against the threats that occur have the same fundamental problem we've been talking about. They can't get to the information. They don't know which remediation to apply at any given moment. And so again, using cognitive systems as a way of going through that information and identifying these are the 3 or 4 plans you ought to be considering and under these circumstances at this moment is a great benefit to those people who have to go perform these kinds of tasks. Next step beyond that then is to recognize the threat as it's occurring and using our cognitive capabilities to identify the signals that indicate ill behavior, something that is unusual, something that ought to have our attention, that's something that has our attention but isn't just sort of another false negative. Because that's the other problem today is that these systems that do try to find and detect for threats are overwhelming our SOC operators with too many false negatives, and therefore they don't have time to go catch the real things when they really occur. So those are all things that we're working on in the cyber security space, and particularly focusing on this offering that we call QRadar. So I'm going to stop there. We're very close to the end of my time, and I wanted to open it up for questions. So first of all, thank you for having me here today, and then we'll open it up for questions.
Ladies and gentlemen, at this time we'll take questions for Mr. High and not Mr. Watson. I apologize.
No, I like Mr. Watson.
Captain Granger, do you have any questions in the booth?
We do.
Okay, please go ahead.
What would you say to someone like Elon Musk or Dr. Stephen Hawking when they speak of the dangers possible with artificial intelligence?
These are really brilliant people, and I always hesitate to second guess what they really are talking about, what they mean to be saying. Look, we have to understand that cognitive computing in its current state, AI as we currently understand it, is not anywhere near the point of being able to replicate the human mind. Even if we thought we had that capability, even if we thought that there was something useful about trying to recreate the human mind and put it in a position of power and influence over our lives, it is highly unlikely that there would be enough economic support for continuing to do so to justify an effort in that space. Now, that's not to say there aren't nation states that won't fund that sort of activity, but on a commercial basis, it's very unlikely that we're going to see cognitive systems evolve to having that kind of capability. The economic value of a cognitive system is about amplifying human cognition, which implies, number one, that there's always a human in the loop, there's always a human involved in that. But more importantly, it is about doing something that we're not good at. Not necessarily thinking for us, not making decisions for us, or influencing and changing our behavior in an overt way, like I think Elon and Stephen Hawking tends to talk about, but rather as an extension of what we are already doing. So the issue there is not the cognitive system, it's not the augmented intelligence. The issue is the person themselves. We still have to focus on who the human is that is using these systems and what they're using them for. That's what we need to be focusing our attention on. That's what we need to be protecting against. I don't think that the technology by itself is the threat.
Next question, please.
There are privacy issues involved in having a cognitive system getting to know a customer so well that they can adapt the system's responses to the customer. How does IBM address those privacy concerns?
So this is a real issue. It's an issue that actually exists irrespective of cognitive computing, although cognitive computing obviously adds additional dimensions. I will point out that it's very common that when human beings are talking to each other, we are exchanging some understanding of each other's personality and emotional state. That's part of what makes it possible and effective for us to communicate with each other. All that said, though, privacy absolutely should be honored and respected. If somebody has decided that they don't want to share information with you, then the system should not be exercising even its perception of who you are to be able to gather that data. And we strongly stand by that. We argue strongly in support of our own clients preserving and respecting that decision on the behalf of their particular clients. That said, if a person opts in, there is a benefit. And that benefit trade-off needs to not only be understood, and therefore these cognitive systems, when they're exposed, need to present themselves in a way that allow human beings to make those choices, to be conscious of the fact that they are being offered the opportunity to say something about themselves, whether that is something that could be derived from their personality, from their interaction, or otherwise, and make that a choice, make that a very clear and explicit choice. So we're a strong proponent of ethical use, and one of the ethical principles that we try to enable for our clients and encourage them to make use of is, the opt-in and a very explicit statement around opting in, the consequences associated with it.
We have time for one more question.
Do you see your cognitive system being mature enough for a large, diverse customer like the federal government to state what our requirements are for a specific objective and receiving with unquestionable certainty a rank order of companies that could meet these requirements?
I think there was two questions in that. Let me parse that. So first of all, our stance is that we want to hand the opportunity to other people to assemble these cognitive capabilities to solve the problems that are important to you. So yes, I do think that IBM, and frankly I would argue that there's a number of vendors that are in a position to be able to support these capabilities at scale across a diverse range of requirements, specifically because we have all collectively, and we in particular within IBM, have specifically identified those services that act as building blocks to higher order solutions. Those solutions then can be constructed. I think the second part of the question was, what vendors do we think are eligible, are qualified for creating great solutions from these services? Which of them are both have the integrity and track history to prove that they can do this? And I'll just simply say blankly, yes, we're happy to provide our position on that.
Thank you, Mr. High.
Okay, very good. Thank you. Appreciate that.